doing 2 more examples. So today, I'm going to tell you ahead of time, the first example is going to be extremely painful, and then the second example will be far nicer. Yeah. Yeah. There you go. Yeah. Okay, example number 2. Solve the triangle. Our givens, the measure of angle A is 32 degrees. A is 13. And C is 17. First things first, we're going to draw the initial triangle and leave space for a second triangle. You will need it for this problem. A, B, C. And our sides, little a, little b, little c. And we'll label the given information. Angle A is 32 degrees, side A is 13, and side C is 17. Reminder at this point, my hope is that you would classify the arrangement of the side and angle information, because this is how you would know to proceed this way about the problem. We have an angle, and then if we go around, we have the next 2 sides after that. So this is an ASS case. If it were the 2 sides that sandwich that angle together, that would be SAS. So make sure you know the difference. Since this is ASS, that triggers the 2 triangle scenario. So set up the space for triangle 1 and 2. I'm going to draw the picture for triangle 2 when I have a better idea of what it's going to look like, which angle is going to be affected. So given this information, we have both A's and then we have one of the C's, so we can use law of sines to solve for the other C, angle C, so that's where we'll start. So finding angle C. Law of sines, we are given both A's, so I'm going to do the A's first, sine of A over A. And these are my givens. Equals, I'm looking for a C, so I need to use the C's, sine of C over C. Filling in, we have sine of angle A is 32 degrees. And side A on the bottom is 13, equals sine of C, and we don't know angle C, so that will stay, over side C is 17. Could you shut the door for me? Thank you. All right, per usual, we're going to cross multiply. And this is the not nice case of cross multiplying because sine is attached to C. We don't have the letter by itself. So this is one where you will definitely want to write out the algebra. Crossing left, I have 17 sine of 32. Equals, crossing right, 13 times sine of C If it helps to write that times there so you know what to do next, then do it. Couple steps here. First, we need to remove the 13 from the sign of C. So I'll divide off the 13 on both sides. Sine of C equals 17 sine of 32 over 13. Reminder, don't use the calculator yet. We'll do that when we have the whole thing solved for. And then how do I move the sign to the other side? What does that look like?
Inverse sign.
Inverse sign. That's when we flip sides. That's when the -1 comes in. So we use inverse sign. And then we just drop all of that down into parentheses below. Of 17 sine of 32 over 13 equals, and then now this is just C. Since we moved the sign to the other side, we just have C over there. Calculator to get our answer. And we're still doing the tenths place on these notes. So second sine. And it looks like to the tenths place, that's 43.9. And this is an angle, so I'm going to put degrees. If you were to leave that off on a test, it's no big deal. All right, so angle C we now know is 43.9 degrees. Now we know that the proposed second triangle is we're testing the scenario that C actually should have been an obtuse angle instead, but we didn't get an obtuse answer because inverse sine won't give that to us. So let's draw the triangle again, and then C is going to have an obtuse angle instead. So I'm going to open it up a bit more on that side. Yes.
Why wouldn't you just go figure out angle B first by doing 180 minus 30 to minus 42.9 and being like, oh, well, the obtuse angle is just angle B?
Because B is a fixed number. B is the default value that's left after A and C. Now, in this triangle, B is obtuse, but again, the problem is we don't know if C is supposed to be acute or obtuse. The question is C acute because it's acute, or is it acute because inverse sine won't give me the obtuse angle instead? Because that's the limitation of inverse sine. It won't give you obtuse angles. So you have to go find it. So this is two possible triangles that could be made with this information. Two answers, not one.
Okay.
This is the only case in the whole unit that it does this, I promise. But it's just like sometimes when you solve for x and you have two answers for x instead of one. Same thing, you can have two whole triangles be the answer. Yes?
And what information do we have right now that tells us we have to do a second?
So we can do this every single time, and sometimes this fails, like yesterday's triangle failed when we tried this, but this one will not fail. We will get two triangles. But if you want the like straight up answer how you can tell without drawing it, angle C is bigger than angle A. So C has the potential to be obtuse. And the only reason we didn't get that obtuse number is because we had to use inverse sine to find it. So, but if C were smaller than A, let me see if I can quickly grab yesterday's example. I don't know if I have it handy. Almost there. Ha. So yesterday when we had this happen, we started with this information. A was smaller than B, so A could not have potentially been obtuse. It wouldn't make sense. It has to be smaller than B. Here, C is bigger than A, so it could be bigger and acute or bigger and obtuse. We have to test both theories, though. So we're drawing the second triangle, and the starter information is exactly the same. going to fill in the sides here real quick. So we have 32 degrees for A, 13 for side A, 17 for side C. And then now we're looking at the alternative answer for angle C. What if C is supposed to be obtuse? What would that number be? That's what we're going to look at next. So finding obtuse angle C, we did this yesterday, but it didn't work out. Where we take 180 minus the value we just found for C. So that would be 43.9 degrees. And we get 136.1. And at this point, we know that this is an acceptable triangle because when I add my current two angles, it doesn't exceed 180, so we're good. When we did this yesterday, again, let me pull this up. When we tried to make that second triangle, this exceeded 180. This is 185.1. That was not okay. That triangle failed. This triangle does not fail. So from here, we now have two triangles to finish solving, not one. So from here, it depends on the person. You can finish solving triangle 1 and then come back and finish solving triangle 2. If I were doing this problem myself, I would finish triangle 2 and then come back and do triangle 1, just so I don't forget about triangle 2. But for notes, just how this is arranged, I think it'd make more sense if I finish triangle 1 on this paper, and then on a separate paper, I will finish triangle 2. So I'm going to hold off. I'm going to come back to this. But we have the second triangle set up. I'm going to finish triangle 1 and then do triangle 2. Okay, so looking back at triangle 1, we need to find B, angle B, and side B. So we're missing both B's. And let's go for the angle. Because we already have 2 of the 3 angles, we can easily find angle B. And one more thing before I forget, because I almost spaced it. When you get the 2 triangles, 1, this will help you, and 2, this is how it will appear on your test. We put 1s, and we just do it on all the letters. Put a 1 on all of them. Only do this if you have a second triangle that you have to solve. But if it fails, you don't have to do this. And then we put 2s on all the letters of triangle 2, just to kind of help you know what you're looking at. Obviously, for me, I try to color code this as best as possible so you understand the purple is triangle 1 and the pink is triangle 2. But even still, that can be a bit confusing. So labeling those with 1s and 2s keeps that information separate. Okay, I'm going to finish solving triangle 1 first. So I'm going to go for angle B. Measure of angle B, we just do 180 minus the other 2 angles. Minus 32 degrees for angle A. Minus 43.9 degrees, that was angle C. That leaves me with 104.1. So now I know that angle B is 104.1. So that was finding B1. And I'll go ahead and put 1s on my work here just to keep it organized. And lastly, we need to find side 1. And again, we have to use law of signs to find missing sides here. So I am going to use the given signs that I used earlier. So sine of A over A equals, and then I need the B's. So sine of B over B. And again, I use the A's instead of C because they were given. I'm going to kind of do the cheat work here where I show as little as possible just because I'm running out of space. But we have sine of our a value is 32 degrees. And then little a is 13. Equals sine of, we know b, it's 104.1. Over little b, which we're looking for. The algebra here is going to be far better than the previous calculation we did because b is all by itself. So we can just do a crisscross. It's just going to be multiplying and dividing, no inverse sign needed. So we have b equals, again, I'm skipping the algebra here, but you're welcome to do this on your own paper. When you cross the two numbers that don't include the b, these are multiplied on top. So we have 13 sine of 104.1. So these are multiplied across, and then whatever's crossed with the b, that's going to get divided over here. Sine of 32 on bottom. So if you do the algebra, don't do the algebra, this is how it's going to end up if you do it correctly. And then calculator to get that final value. $23.8. So that's B1 is 23.8. I know it is a lot of steps, yes. I'm not a fan of these problems either. Okay, so that's going to go into my value up here. Okay, triangle 1 is solved. Now we need to repeat those same two steps for triangle 2. Solve for angle B2 and then find side B2. And I'm out of room, so I'm going to get a new piece of paper to finish this off on. Okay, so next I'm finding angle B2. So we have 180 minus, and I'm going to get that first triangle out of view here because this is where it could be very confusing if you're looking at the wrong triangle when you're writing the stuff out. So make sure you're keeping track of what you need to be looking at. So we have angle A, which is 32 degrees, minus the obtuse angle C, the new angle C, 136.1. And the remaining angle is 11.9 degrees. So angle B2 is 11.9 degrees. And lastly, we need to find side B2 here. Again, this is where we use the law of sines to solve. And just like before, I'm going to keep using sine of A because that's what was given to me. So those are the most trusted numbers, the best numbers to use. And then I need the B's. So sine of B over B. And again, make sure you're looking in triangle number 2 when you set this up, not triangle number 1. So we have sine of A. So since it's given, those numbers aren't going to change from before. It's still 32 and 13 equals sine of B, which I just found, 11.9, over side B. And now we just cross multiply. After you cross, again, I'm skipping the algebra here. So we cross the two numbers first, 13 and sine of 11.9. Those are going to be multiplied on top. And then on bottom, whatever gets crossed with b, so sine of 32, that gets divided here. And then we round. And I get 5.1 as my missing side. So B2 is 5.1. And both triangles are finally solved. So all of this together, both triangles and all three parts and both missing have been found. That is the answer to this complete problem. This one problem. And I promise you the test isn't going to be full of them, but obviously you need to be well aware of how to handle this when the test comes. Okay, let's do the easy example, the quick example. And that's as bad as it's going to get. I have shown you my hand. Everything else from here should feel not that bad. Okay. Solve the triangle. Given measure of angle A equals 60 degrees. A is 5, and A and B is 14. So we'll draw our first triangle, ABC, and label the sides, little a, little b, little c. A is 60 degrees, angle A. Side A is 5 and side B is 14. Again, at this stage, take your given, set up your triangle, classify it, identify it. We have an angle and then going around, we have the next two sides from there. We do not have the two sides that contain that angle, so that's not SAS. This is ASS. ASS means two potential triangles. Now I'll go ahead and tell you, because I already said this is an easy example, we will not have a second triangle, but always set it up just in case. Because if you leave it off, you're leaving off half of the entire answer. So it'd be a big deal. So if we need a second triangle, I've got the space dedicated to it. From here, we just have to start solving and see where we can go with it. We have both A's and then a B, so we're missing the other angle B. We'll use law of sines to get there. So let's find the measure of angle B. I'm given the A's again, so sine of A over A. And again, I'm using those because they are given. And then I want a B, so I'm going to use the B's. Sine of B over B. Filling in, we have sine of angle A is 60. Side A underneath is 5. Is equal to sine of angle B we're looking for over side B we have, that's 14. And then we cross multiply. Since B is not alone, it has a sign attached to it. This is when I strongly encourage you to write out the algebra. Crossing left, I have 14 sine of 60. Crossing right, I have 5 times sine of B. First, we need to get rid of that 5 in front of the sign, so divide it off on both sides. Sine of B equals that fraction. And then we need to move the sign to the other side, so we have to use inverse sign to do that. So when it switches sides, it gains a -1 there. Bring that whole fraction down. 14 sine of 60 over 5 equals, right side, that sign is now gone, it flips sides, so it's just B. Yes.
I keep on getting syntax errors.
You get syntax errors?
Yeah. Or like error domain.
There you go, that's a different one. Yes, that's what you're supposed to get.
I put that in like 8 times. I keep
Yep.
forgetting.
So that's why I said this is going to be the easy one. So when you type this in, you get domain error. If you get domain error, that means that something that can't go into that function was attempted to be entered. This is another flaw with inverse sign and with the ASS case. Sometimes it will try to give you triangles that just don't work. You just can't make a triangle out of that. So sometimes this does happen. This would essentially be the equivalent of a no solution kind of problem. So this is just for notes. You don't have to write this down unless you want to, like if you were doing homework. But you get domain error when you type it into the calculator. If you get syntax error, that means you specifically type something in wrong. Go back and look at it. But domain error, something else is going on here. So since we can't get a value for B, we can't even solve this triangle, let alone set up a second triangle. So obviously the problem stops here. Now what we write as a final conclusion, on the test it will be worded no such triangle. So you can do that. That's a shortened way to write it. I'll give you a couple options. This other one I think is just pretty intuitive way to say it. Triangle does not exist. Which you can even shorten to triangle DNE. Something like that. So either of these on your homework would be fine. Just know on the test, you're going to see the words no such triangle.